Let's see what is the Kirchhoff's second rule. It states that the algebraic sum of voltage changes in a closed circuit or a loop must be equal to 0. Consider a closed circuit shown in the figure 13.21. The direction of the current I flowing through the circuit depends upon the cell having the greater EMF. Suppose E1 is greater than E2, so the current flows in a counterclockwise direction. We know that the steady current is equivalent to a continuous flow of positive charges through the circuit. We also know that the voltage change of potential difference is equal to the work done on a unit positive charge, or energy gained or lost by it in moving from one point to the other. Thus, when a positive charge delta Q due to the current I in the enclosed circuit figure 13.21 passes through the cell E1 from low to high potential, it gains energy because the work is done on it. This equation 13.212, the energy gain is E1 delta Q. When the current passes through the cell E2, it loses energy equal to negative E2 delta Q, because there the change passes from high to low potential in going through the resistor R1. The charge delta Q loses energy equal to minus R1 delta Q, where IR1 is potential difference across R1. Minus sign shows that the charge is passing from high to low potential, and similarly the loss of energy while passing through the resistor R2 is minus R2 delta Q. Finally, the charge reaches the negative terminal of the cell E1, from which where it started. According to law of conservation energy, the energy total change in energy of our system is 0. Therefore, we can write E1 delta Q minus IR1 delta Q minus E2 delta Q. So IR2 delta Q is equal to 0. E1 minus IR1 minus E2 minus IR2 is equal to 0, which is Kirchhoff's second rule, and states that algebraic sum of potential changes in a closed circuit is 0. We have seen that this rule is simply a particular way to stating law of conservation of energy in electrical problems. Before applying this rule for analysis of complex network, it is worthwhile to thoroughly understand the rules for finding the potential changes. If a source of EMF is transferred from negative to positive terminal, the potential change is positive. It is negative in the opposite direction. If a resistor is transferred in the direction of the current, the change in the potential is negative. It is positive in the opposite direction.